Hello, my name is Amy, and welcome to my physics travel vlog. Today, we're going to take a look at a trip to Paris and London and explore the physics principles we find along the way. So where does our trip begin? Well, for me, I needed to purchase my plane tickets, so I logged onto my computer to do this. Modern computer systems are based ultimately on quantum physics. However, they use the quantum effects of materials essentially to simulate classical physics. After I have prepared for the trip, I need to set my alarm. This way, I can get up in time to arrive at the airport. Physics principles are also used when the alarm clock sounds off. Sound energy travels through in airwaves. When an alarm clock rings, nearby air molecules vibrate. The air molecules jiggle about and make neighboring molecules vibrate too, starting a wave of energy that travels out from the clock. When I get to the airport, I need to check my baggage and pass through the airport security. My carry-on luggage passes through X-ray scanners, and I pass through a metal detector. These technologies use relatively high-frequency radiation. Once I have cleared security, it's time for me to head to the terminal and board the plane. We could spend all day talking about the physics involved in flight. The physics of flight requires that lift, drag, weight, and thrust happen at the correct time and in the proper amounts. For an airplane to go in the air, the lift has to be stronger than the force of gravity. Lift happens at the wings as air passes over them. When a plane is landing, it requires reduced thrust and lift to bring it back to the ground. We can thank George Cayley for these advancements. The seat belt on the plane is another example of physics at play. The seat belt keeps you from being ejected if you were to experience turbulence or a bumpy landing. It uses the basic principles of force to employ its job. Something that I think about when in flight is Einstein's theory of relativity. Einstein spent a lot of time determining that massive objects warp the fabric of space-time. According to Einstein's general theory of relativity, time moves faster in the absence of a gravitational field. The higher up you are, the further you are from the Earth's mass, which means slightly less gravity for you and a slightly faster clock. While standing, even your head is ever so slightly moving a bit faster through time, since it's a meter or two above the ground. When we arrived in Paris, we walked a lot. You wouldn't think so, but walking requires physics as well. The principles of force and friction are applied when walking on various surfaces and when using different types of shoes. We also took a bus tour in London. The buses in London run off of a diesel engine. This type of engine runs off the energy provided by the combustion of diesel fuel under high pressure and temperature. Engines also require thrust and force to move the vehicle forward or backward. We experienced two iconic landmarks on our trip. First was the Eiffel Tower, and yes, physics can even be found there. The Eiffel Tower has a very distinctive shape, which was based on basic physics to protect it from high winds. We also visited the Tower Bridge in London. When the Tower Bridge was first built, it operated off of steam boilers, but has since evolved to use hydraulic systems. Physics can be found everywhere, even when using the ATM in Paris. We use principles of electricity and magnetism. Our cell phones use power through frequencies and radio waves. The adapters that we use are run on basic principles of electricity, and our digital cameras come equipped with sensor chips, which aid in breaking up pixels and creating digital photos. Physics extends well into your everyday life, describing the motion, forces, and energy of ordinary experience. In actions such as walking, driving a car, or using a phone, physics is at work. For everyday living, all the technologies you might take for granted exploit the rules of physics. I did employ my scientific skills while on this trip. The tools I found were in the scientific method. I wanted to heat up some pastries that I bought earlier on in the day, but my hotel microwave would not work. So here's what I did. I observed that the microwave would not work, so I asked myself the question, is something wrong with my electrical outlet? Then I formed my hypothesis. If something is wrong with the outlet, my coffee maker also won't work when plugged in. I conducted my experiment by plugging the coffee maker in. When the coffee maker works, I concluded that my electrical outlet worked, but my microwave must be broken. Well, this is the conclusion of my travel vlog. I hope you have enjoyed discovering how physics is at work in our everyday lives. Now you can find places to apply these principles too.